Okay, people still seem to be having trouble with the graphing of polynomials and rational functions in determining the sign of the function on the various intervals. Now, let's be specific on this, okay? You locate all zeros of the numerator and the denominator. Of course, if you have a polynomial, you won't have a denominator with zeros. But if you have a rational function, your denominator will or might well have zeros. Then you determine the sign on each interval. And we can do that using common sense if we have decent number sense, but even if we don't, we can pick a point in each interval and evaluate the function at that point, or at least evaluate the sign of every factor at that point. Excuse me. So, looking at this function, I'm assuming everybody knows how to get the zeros. When x is equal to 4, the whole thing is going to be 0. The numerator is going to be 0. Okay, so I'm going to put a little x here at x equals 4. When x equals 1, the numerator is going to be 0, because you plug in 1, do it yourself. If you don't believe me, you're going to get 0. And if x is equal to -6, you're going to get 0. Now, people seem to be okay with this part of it. Okay? Now, 0 is the denominator. That's when x equals -3. And as we've discussed, 0, the denominator, means that you can't evaluate the function anywhere on this vertical line. So this is a vertical line, x equals -3. Now this is going to turn out to be a vertical asymptote, but we'll talk about that separately. Okay, so we have intervals. The only zeros between 1 and 4, there are no zeros between 1 and 4. The only other zero of this function is at -6, and there are no asymptotes between 1 and 4. The function can't change sign because it's got a continuous graph, except at these vertical dotted lines where it's undefined. Okay? The graph is nice and continuous and connected. If it is, it can't go through 0 between here and here. If it did, there'd be a 0 here, and there isn't. Any other number except 1 and 4 and -6 is going to give you a non-zero numerator. Okay, you got to know that. And I hope you took a note on that last comment. If you didn't, I'm not going to keep prompting you to take notes. You have to take notes when something is said. Okay? You have to stop the video even if you're in a hurry. Take a little bit of a note. Okay. So, between 1 and 4, there are no zeros. So that means that the thing is either always above the axis between 1 and 4 or below. We don't have to decide which at this point. Later on we will. Actually, we're going to decide right now. But we don't have to decide before we test. Okay, so we can pick a number between 1 and 4. So let's pick 2. At x equals 2, x minus 4 is negative. You can test that if you want, but 4 is bigger than 2 and you're subtracting. Okay? So it's, can I write negative? At x equals 2, x plus 6 is positive. 2 and 6 are both positive, so it's positive. At x equals 2, x minus 1 is clearly positive. 2 is bigger than 1. And the denominator, x plus 3, is positive. So you have multiplications and divisions of a negative number with a bunch of positives. That makes it negative. So the graph is going to be below the axis between 1 and 4. If x is greater than 4, then you can test it. Pick we could pick 5, but 10's better in case you have a square in here or something. It's easy to square 10. Excuse me. At x equals 10, x minus 4 is positive, x plus 6 is positive, x minus 1 is positive, and so forth. So we have positive, positive, positive over positive, and that's positive, meaning the graph is going to be above the axis. At x equals 10, and since it can't go through the axis between 4 and 10, because there are no zeros, it's going to stay 10. Okay, between -3 and 3, and 1, I'm sorry. Well, this interval includes the y-axis, so we can let x equal 0. At x equals 0, we get -4, +6, -1 over positive, and that's positive. Now while we're at it, we might as well go ahead and multiply those numbers. We get 24 over 3, which is 8. So we can even say that the y-intercept here is at y equals 8. Okay, between -6 and -3. Pick an easy number between -6 and -3. At x equals -4. Uh-oh. No, that's right. Peripheral vision. Okay, at x equals -4, -4 minus 4 is -8, that's negative. -4 plus 6, 6 is bigger than 4, is positive. -4 minus 1, that's 2 negatives, it's negative. And -4 plus 3 is negative. So we get negative, positive, negative over negative. And that being a product of 3 negatives, or product quotient of 3 negatives, and a positive is going to be negative. To the left of x equals 6, and let's just go to x equals -10. Well, you can test it out. Every factor is going to be negative. Now, if you combine this with everything else that we know about the function, it's going to get really big if x is negative because you've got a bunch of x's up here and just one down here. And you can multiply it out, even for x equals -10, it's going to be pretty big but negative. As you approach x equals -3, uh-oh. You know, I said something ignorant here. Said you have negative, negative, negative over negative equals negative because I'm talking without thinking. Obviously, that's a product of 4, product or quotient of 4 negatives. It's going to be positive. I was going to get in trouble because I needed a negative asymptote here. And if I come up here and down here, I don't have the right kind of a 0. And we'll talk about that later. Okay? Now, at this point, we can draw the graph, but this is how you determine the signs. And if you're making errors with the signs, I want you to tell me where you evaluated this. Okay, I want you to tell me the points at which you evaluated it. And make sure you're right. You can do the calculations. You don't really need to do the calculations because you can see, if you know what the number is, you can see what each one of these, whether each one of these is positive or negative, that's all you need to know. You don't need to know the value. Okay, so anyhow, that's it. Now, if you want to sketch the graph, just as a little icing on the cake, we'll sketch a graph here. It's going to come down from large positive numbers. It's going to level off maybe a little bit here, and then it's going to approach a negative asymptote. And then it's going to be positive here, so the asymptote's going to have to come down from here. Going to have to go through 8, and then down through the y-intercept at 0, 8, then through the x-axis at 1, 0. So it's going to come down from way up here. It might do this. It's going to go negative here, and then it's going to go positive here. Might well look something like this. but I'm not gonna go into big discussion of that, that's done elsewhere.